Hello everyone, this is Guotao Meng. I'm going to present our work embedding novel views in a single JPEG image. This is a joint work with Yue Wu and Qifeng Chen. All the authors are from the Hong Kong University of Science and Technology. Novel view synthesis allows users to view a photo in 3D from different viewpoints, which creates a more immersive experience than a 2D image. However, usually the novel view synthesis models are large in file size and need a specific viewer to view them. Thus, it is expensive in network traffic to share them on social medias, and they cannot be viewed by a general user with a regular phone or web browser. Besides, a large amount of storage space is demanded to save them. To solve these problems, we propose a novel approach that embeds a model into a single embedding image that can be converted back to view from different viewpoints. We adopt the popular novel view synthesis representation of multi-plane images, also known as MPIs. Our model first encodes 32 MPI layers into a JPEG image. Then this JPEG image can be converted back to an MPI to render novel views. Let's see a typical application of our proposed method. How can user A share a novel view synthesis model with others on social medias? One plausible strategy is to embed this model into a single embedding image that looks like an ordinary JPEG image. On the one hand, when user B receives the embedding image shared by user A, user B can view it as an ordinary 2D image. On the other hand, user C with a plugin which contains a restoration network can see this image in 3D from the restored novel view synthesis model. To enable such user-friendly applications, we propose our framework. The features of the RGB layers, the alpha layers, and the reference image from the MPI are first extracted by the CNNs respectively. Then these feature maps are fused together. To fuse the 32 RGB feature maps, we design a fusion mechanism with the alpha layers. Since the alpha layer represents the transparency of each RGB layer, we fuse the RGB feature maps by a weighted sum operation, and the alpha layers are used as the weight maps. Then the fused feature maps are processed by a unit like CNN to get the embedding image. When users distribute a photo on social medias, they may apply some photo filters for a better appearance. So we perform the JPEG compression, a series of random fine color transformations, and the random cropping to the embedding image to make it robust to these manipulations. All the operations are implemented with differentiable functions. Then the embedding image is processed by a lightweight network to restore the MPI. The MPI can be used to render novel views. The restoration network and the renderer can be implemented as a plugin for apps and web browsers. Because information is embedded in the image, evident high-frequency patterns appear on the embedding image in the previous methods. To suppress such artifacts, we introduce a novel frequency domain loss. We first convert the embedding image and the reference image into frequency domain with FFT, then enforce them to be close. Using the frequency domain loss, together with the reconstruction loss and the adversarial loss, the colorful strips and the dots artifacts are effectively alleviated. Then let's see some results. We first show the embedding images, then the render novel views from the restored MPIs. The res unit is implemented as a naive solution for this task. The embedding network and the restoration network are implemented with the res unit. The video snapshot is the most relevant state-of-the-art work that embeds 8 consecutive frames into one image. The results show that our method can recover high-fidelity novel views from a slightly modified JPEG image.